We're going to start by looking at a two variable Kmap. So two variable Kmap would be I have an expression f made up of just a and b, for example. All right, when we talk about a Kmap, what a Kmap is going to be is it's going to be made up of a couple of different segments. One segment is it's going to be a graph or a grid that we're going to create. The next item that's going to be important is something called that we're going to have locations adjacent. And this adjacent item is going to become very important. All right, so let's start off with the grid item. What we're going to do is we're going to make a grid. And for two variables, it's going to be just 4 boxes. And in these 4 boxes is on the side, we're going to define our variables. So let's say it's A and B. And I'm going to give every box a 0 and a 1 value. All right, on the top part here in blue, A, it has its own 0 and 1. And then in green, we're going to see that B has its own 0 and 1. And then every element inside the box, so if we look at this box right here, this is A is 0, B is 0. The next box is A1, B1, A0, B1, and then an A1 and a B1. So every box will have its own coordinates. Now, why are these coordinates important? Because if we were to take these boxes and let's get it connected, if I write them out as midterms, so let's say it's A bar, B bar, an A and a B bar, an A and a B, and an A bar B, we have these 4 variables that are set up. And what we're going to look at is we have items that are adjacent. So adjacent is what we're going to look for is I could take one box. Let's say I take this box of A and B bar, and adjacent would be it's orthogonal to 2 items. It can go down and connect, and it can go to the left and connect. Okay, in these connections is let's take one of these connections. So let's just take, if I had A, B bar, and let's take the one below it, and let's say that made up my 2 variables. Well, this ends up being a reduction that can be made. You know, here's my X and a Y bar. Here's my X and a Y. Well, that just turns into X, which would turn into an A. So we can see if it's adjacent, we're going to have that quick, easy reduction be possible. Let's take a different one. Let's take here in orange. Let's say this was the one I'm connected to. I'm adjacent to 2 items, above and to the right. So let's just take the above one. That's A bar, B bar, plus A bar, B. And again, I have my X and my Y bar and my Y. But that's just X. You know, that term just comes out to be A bar. So how are we going to use this Kmap? We see that we want stuff adjacent. Well, when I make a Kmap, inside each box, since I'm giving every box its own value of 0 and 1 for A and B, each box is either a midterm 0 or a max term 0. That's 0, 0. The one below it's going to be midterm 1 or max term 1. The next one is midterm 2, max term 2, midterm 3, max term 3. All right, so let's say we have an equation. Let's say we have f of AB is my midterms of 0, 2. All right, so from this 0 and 2, we're going to use it and we're going to fill in a Kmap. And what this is the midterms are going to tell us locations of a 1. All right, so we have our box that we're creating. I have midterm 0 and I have midterm 2, so that's the two top boxes. I can fill in all the rest with zeros because if it's not a 1, the only option is the 0. All right, so then I have this Kmap, and then once we have the Kmap, we're going to look for adjacent items. Okay, so I'm going to look for adjacent items, and what we do is we're going to group adjacent items together. So we're going to group the adjacent. And when I group the adjacent, what we're saying is, I have A bar, B bar plus A, A B bar. I'm going to keep this B bar. That's all that comes out to be. Well, we want to be able to figure out what the reduction is without writing the variables. So can we do the reduction without writing out all the terms? Well, yes, it's going to be possible. We're going to use the map itself to tell us what stays and what goes. So let me rewrite this out. Here I have my two ones. And what we're going to do is once I make a group together, we're going to write down the terms that do not change. So we look at this. Here I have B. B was a 0. Here I have A. A took both values. I used the first column. I used the second column. There was a change. The change we do not write. So all I'm going to say is this term here, this F, is equal to what stays. What stays is B of 0, which is B bar. Let's do another example. Let's do that I have a column being used. Well, I'm going to look for something that's adjacent. Okay, I find something that's adjacent. I look at A. I look at B. Well, we had a change on the B, so I'm not going to write it down. I'm going to say, F, it's just A. Why is it A? Because we're in the one column of A. If we're writing midterms, we're just leaving it as the letter itself. All right, let's do another example. Let's do an example that we have A and B. And let's do that we have 3 ones here. All right, so I'm going to do this. I'm going to group here. This grouping is, I'm looking at what's staying the same. What's staying the same is B bar. And then I can say, you know what, this bottom one, oh, that also is a group itself, and that's A bar. So then I would say my final solution is both of these combined. It's A bar or a B bar. Well, it's going to be possible that maybe instead I have nothing that's adjacent. Maybe I have this setup. Well, it's possible if you have this setup, you say, all I do is I have a single one together. Well, that's my answer. My answer is just that one group by itself. In that time, it's going to have 2 variables. It has an A bar and a B because both of those did not change. Well, what happens if we have something that has no ones in it? It's all zeros. Let's say we had something for whatever case this ended up to be. We have no groups. You say F is a 0. They're all 0. Same thing would happen if the entire item is filled up with 1s. If everything is filled up 1s, we say it's one big group. And this one big group is just the value 1. Sometimes it's going to be possible that we have an equation that looks like f is a of b of midterm 0 with just a don't care. Let's say it's don't care 1. Okay, so what is that going to look like is, let's draw out our item. I have a 1 at midterm 0. At midterm 1, I have a don't care, so I'll put a x in for a don't care, and then the rest ends up being zeros. Well, when I have the option of an x, when we see an x, a don't care, we have the option of using it as a 1 to reduce. We don't have to use it. It's our option. So here I could say, I could see it, I can use it. It's adjacent. It's going to be next to it. That gives me down to an A bar. If I didn't use it, and I said, I don't want to use it. I'm just going to use it as a single 1 by itself. But that's A bar, B bar. So if we're going to compare these two, the least number of terms the smallest number of terms and the smallest number of variables is best. So in that case, I would say, which option do I want? Do I want A bar or A bar, B bar? It's clear. A single term is better. So we're going to have the option that we can keep using these don't cares only if they help the situation. All right, so that gives you the idea of 2 variables. Later on, we're going to start adding in a few more variables along the way.